right, welcome everybody to another session of Office Hours. This is Saturday, June 17th. We'll start the session today just by asking if there's any questions about any of the content that we've covered so far. I do have some emails that people sent in with Office Hours questions, so that's the situation where they've sent me a file, so I've got something to work with and a description of what they're trying to accomplish. So that's what we're going to take a look at. So the first one we've got here, looks like Kenan, are you having any trouble with your connection? I noticed you dropped out and come back in a couple of times. I'm going to cover your question, so just I hope you've got a decent connection in case you want to communicate about what's going on. So we've got an email here. So I've attached a zip folder with the files needed. It looks like it's an older post. So my main concern at this time is the retract that it does. If you put only one operation with, say, one tool, everything looks good. But say you post out two operations with that tool on the second operation, the tool will go to its clearance plane, then go back up, then down to the cut plane. I figured I'd start here because I wanted to implement a couple things like the MI2 function I used from this post to a generic post I've configured pretty close. Okay. This is a positional post. By positional, I mean that you have to rotate your coordinates exactly as the machine will rotate, or else it will not put the right rotation, so that it doesn't have triggers built in to figure out rotation like the generic 5-axis post, and it doesn't use any of the matrices. It's really confusing to me, to be honest, but honestly, I've only been doing this for 6 months. It's self-taught, so I think it's all right. So this is a big thing. This is a positional post, so it sounds like you're actually manually entering the rotational coordinates. So that's kind of never a good thing. The 4-axis post has the logic in it to automatically calculate the rotary axis for you. So it sounds like there's a couple of in some cases, it ends up that creating a new post is far less work than trying to continue using a post that was never set up properly in the first place. So let's take a look at some of that. So let's see what we got. There we go. Okay. So it looks like this is for a feeler. And Kenan, what type of machine is this? Feeler. It's a 4-axis positional. Is it a vertical machine? Is it a horizontal machine? And if you want to jump on, you can. Okay, I can't get my audio to work right. Hopefully, I'll be able to view the video soon. Here, let's try this. Yeah. So Ken, try and do this. Try and call into the meeting using a telephone. Anytime you're having trouble with your computer audio, the best solution is always to call into the meeting. So when you do that, there's a setting that allows you to switch between computer audio and phone call. So that's always the best. I don't know if you can see the window that the control panel basically, but that's the best way to try to do it. Here, I'm gonna switch over just real quick. See if we can see anything up at the top. Vertical 3+2 trunnion. Okay. And it's a Fanuc 31 machine. So that's interesting. Work offset, -1, 54, 1 is 54, 2 is 55, 3 is 56, etc. 7 through 20, G54.1, P1 through G54.1, P16. So it's always important when you're working with any post to kind of read down through the top. In general, and this is a good practice for you to get into as well, I'm going to turn off the display of the white space. Make sure that auto convert tabs to spaces is still turned on. Sometimes that'll help with readability a little bit if you turn that off. So in general, up at the top of the post, you're going to see a bunch of comments that are put in by whoever wrote the post that give you an idea of what's going on. So this is talking about features, using the work offset function in Mastercam to output a work offset value. Then it says use the point toolpath with the tool number 0 at the front of the program to set up global set point and loop vars, etc. Use the operations misc integer and misc real values to control how the variables are set up. You can use the view work offset to control which work offset and the global repeat loop to use, if any. To use the work offset for G5459 without repeat loop, use 1 through 6. To use the work offset for global repeat loop, set to global repeat loop times 10 plus work offset. So this is interesting. Yep, sorry Ed, thanks man. Okay, so it looks like Ed had to head out. So this has got some funkiness built into it. So repeating and looping and stuff like that. Down here, miscellaneous values override the work offset function. So misc values for null tool 0 integers, MI1, set to whether or not to set up global repeat loop. Okay, so 0, don't set up any global repeat loop. 1, set up global repeat loop. So looks like MI1 set using 0 does nothing, turning on 1 turns on the global repeat loop. MI2 work offset to set up, if any. 0, don't set up G120 line, or 1, G54, 2, G55. MI3 set to number of pockets for loop. MI4, if MI2 equals 0, this controls whether or not to set up points 0 or 1 equals 0, don't set up. So this is very interesting because there's a lot of stuff that's going on in this post that was set up for some very kind of customized operation. MR3 set to amount to index between pockets for this loop. Wow. Miscellaneous values for tool numbers other than 0. Yeah, so this is a very old post. I don't see anything in here about when it was created. Ooh, MP4. So, Canon. This post was created a very, very long time ago. This is about 30 years old, roughly. 27 years, something like that. MP4 is a very, very old version. Yeah, so, I mean, MP9 or 9.1 or whatever was when we were using version 9. This was set up for Mastercam 4. I can almost guarantee you would be much better served by taking a generic Fanuc 5x mil post and setting it up from the start for your machine. Because there was so much stuff that was missing in the MP language that is available to you now. Starting with version, I think 7 or 8 is where they developed the generic Fanuc 5x mil post, and that's where they took kind of all of their knowledge of 5-axis and built it into a single post processor that you can set switches, and with the setting up of switches you can configure the post for basically any type of 5-axis machine. It can be vertical or horizontal, it can be table-table, it can be table-head, or it can be head-head. And it can also be nutating. And a nutating machine is where the rotary axes are not set at 90 degrees to each other. Typically it's either a 45 or a 50 degree arrangement. So we'd have to see kind of what this post does, if there's anything special from the looping standpoint. Let's see what else we got here. Miscellaneous values for null tool 0. Set to whether or not set up global. 210 line. Bum, 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 bum. So it's very, very interesting. Yeah, so you can see that basically this was set up with just some of the very old variables. It's just taking the raw XYZ value from the post. And obviously there's basically sets up a G10 line in the beginning. Yeah. Which loop to use and loops. Man, this has got a lot of stuff going on in it. Be interesting to see what the output looks like. Tell you what, let's do this. Let's go open up. So we got a bunch of point ops. Oh, let's see what we got. This back plot will show an invalid tool. So let's go look at your null tool here. The point toolpath sets up my G10 lines. Got you. Okay. So we have to have something in here. We can't just have every. See, yeah, I mean, you're doing some things that you're creating a lot of extra work for yourself. So in order to create a G10 line, normally we just read the tool plane matrix, figure out where, if there's a rotation, and grab the distance, the XYZ distance, from some point to set up the output of your G10. So, not to say that whoever did this, it looks like whoever set this up originally kind of knew what they were doing, but the tools they had to work with were just really limited. So they were getting 5-axis output, but there's a lot more work involved than you really need to do. So for example, you've got a null tool where everything's 0. You can't even backplot it. I guess it's not, all I need is the rotations. Yeah, no, I know what you're doing with it. You're using that to output the G10 stuff. So enter the main program number. B and T and W. This is very interesting. So I'm assuming the T is the second rotary. Yeah, it's set up in the 9013 program. Okay, so you're just passing 90 in the variable T. Is the T an angle? Okay, and these are, I'm guessing, are calculated from the orientation of the tool plane. Okay, okay. Well, that makes sense then. To do this in a modern post is not that hard. It's a little time consuming, but not that bad. What we normally do is build, in your case, you're building a macro, G65 9013 is the macro number. Normally what we would do is do that on a regular Fanuc with a G10. Sounds like you've got your own custom macro, which is just fine. But we should be able to take these rotations from the calculations in the regular 5-axis post. Let's see if we can at least try and solve your problem. One operation with one tool. Everything looks good, but when you post out 2 operations with that tool, on the second operation, the tool will go to its clearance plane, then go back up, then back down to the cut plane. So, you're talking about a situation like this with 2 operations that share the same tool number? Okay, so we got clearance, 1-inch incremental. You're not using reference points, so that's okay. 100 incremental. That's good. And then we've got this. Incremental. I don't know if we're going to need this as part of the output, but we'll include it there anyway. Should be able to post out 2021 to see it. All right, so 20. Okay. So what do we got here? We're going down, we're doing the cutting, and it's outputting the reference return G91, G28, Z0. What we need to see, yeah, and it's the same rotation in between. So if you switch to a modern post, this is already taken care of for you because it knows to detect tool change versus null tool change, and it knows how to detect rotation change. So it actually keeps track of what your tool plane is set to and looks to see if the tool plane has changed. And if the tool plane has changed, then it forces out the retract. If it hasn't changed, it doesn't. But we should still be able to see where this came out from in the post. So let's see if we can get you your answer. I'm going to change these NC file name. And I did that to separate them. So now I can post without getting a warning about not having all those operations selected for the same NC file name. So, window, tile horizontal, and typically, like normal with the debugger, debug, run turbo. Oh, and it's paused. So right now, this is another thing that happens with the debugger. That I sent you in my sample. Okay, well, regardless of that, we should be able to find where the output is coming from. So let's see if we can at least find where the output is coming from. Right now, it's paused. The entire posting process is paused because Mastercam has a prompt. So I got to go back to Mastercam. And enter my data, and then we go back to, okay, thank you, go back to the post, and now we can examine the output. So now we go back up to the top. This is what we're getting for output. So here's the operation. Here we're doing the startup. Here's where it goes down in Z. You can see the G43 line. Then you can see PZ rapid, and then we start getting output: plin, plin, PZ rapid, PMX0. So all of these are post block calls. We get down to the bottom, and you can see that this move is called by the PZ rapid. This one here is called by P tool change 0. So it is this line is coming out from the null tool change post block. So what we could do then is go look a little bit deeper. Now this post is a 5-axis post. You post out operations 21 and 32. All right, we'll try that. So let's go back here. 21 and 32. Now we do have to look here. Okay, tool plane is front top of curve B45 A90, and this one is back coolant hole B97 A33. All right, well, let's post these out. So Oh, you know what? This is going to make it 2 programs. Yeah. Okay, so here's those 2 ones coming out. So which line are you looking at here? Yeah, I'm not set to post to Code Expert. Okay, so we got 49, 50, and 51. Well, it could be miscellaneous values. I mean, you do have a ton of stuff going on in this post. So the default here automatically set to post values when posting. I don't know if you've got different settings here. So that's always a possibility. I mean, this is definitely a very old and very funky post. One of the interesting things, if we do look through it, so here's a bunch of initializations, some various variables and matrices that were created, some global formulas, canned text support. As we get deeper in this post, I wouldn't be surprised if the 5-axis logic is actually open to us, because there is no PSB for this post, so it's only a PST. Yeah, PMX0. So here we're doing figure out index rotation. Here's so atan2 is a math function in the post that calculates an angle between 0 to 360 using the endpoints of some vectors. So all of this right here, you can see that here they're doing this value times this value plus this value times this value, and then taking the square root of that to find the hypotenuse. Very interesting. So yeah, here's some of the calculations. Here's some of the calculations right here. atan2, row x, row z. Man, this is some old stuff. That's amazing. It's amazing that it still works. Go to start position. Global. It'd be interesting to see what you do with this number of loops and pockets and stuff. A bunch of macro calls. Very interesting. Still, okay, so let's go see where some of that output is coming from. I'm going to go back to 20 and 21 here. We'll run it through the debugger. We'll go to the debugger and hit run turbo, start this off again, and then back here, enter a little bit of data. And let's check the output. So we were looking to see where's some of this data coming out. So we look at the first operation here, and then we're getting this return to 0 and it's starting at P tool change. If I double click on P tool change, right here, this is showing where inside P tool change 0 that output was taking place. And it's, you notice it's highlighted over here in bold. So I was able to hold down the control key and use my mouse wheel to scroll and blow this up a little bit. So what happens inside this post block? Null tool change. Besides the fact that it keeps doing that annoying annoying sound. Here, let me do this. We're going to turn down my volume a bit. That's better. So how do we read this logic? It's something that'll be important to start learning as we start learning about variables and strings. Once we get variables and strings and formatting figured out, then we'll start getting into understanding Boolean logic. So, in this section, we have one condition that is followed by an else condition. So if tool $, which is the tool number, is greater than 0, if that condition there is true, we're going to execute all of the code that's contained between this set of square brackets. The square brackets mark the start and the end of a user implied post block. And an implied post block simply means this is a grouping of post lines, and when the condition is true for us to enter that group, we're going to execute all of the lines until the group of lines is completed. So if we start with an open bracket and we actually make it inside this block of code, we execute every line. How do we make it inside the block of code? The only way to make it inside this block is for this condition to be true when we are processing null tool change. So every time P tool change 0 gets called, we check the value here of the tool number. So the only time it's going to be 0 is at the very start of the posting process when we're outputting those G10 lines. That's a custom functionality that's built in your post. So when we're processing the actual tool numbers, now we start with the first line of code. CUR underscore SPDL equals speed. What can we tell about this line of code right here just by reading it? So whenever I'm reading these lines of code, I'm always looking for what are we trying to do with this logic and what is it related to. We have a variable here named speed. Okay, that to me sounds like either some type of rotational speed or maybe a feed rate, but in general, motion in the post is described as feed and rotation is described as speed. And then cur SPDL. So maybe it stands for current spindle. That's probably what I would deduce from just looking at the names. That is that we are saving the value of speed into current spindle, or we're just setting the current spindle equal to the current speed. So then we come down to the next line of logic. If the value of current spindle is greater than max spindle, current spindle equals max spindle. So this is a little bit of code that's put in for safety. And what it's doing is it's checking the current spindle speed, and it's checking to see if it's greater than the max. If it is greater than the max, we simply take whatever the current value is and we set it to the max. Okay, so this makes sure we can't go beyond the max. What happens on the next line? If previous speed does not equal current spindle speed, cur spindle $. So what is this line of code here? Is it part of a formula? What are we doing? It's a Boolean test. So we have the if condition, if this condition is true. So if the current value does not equal the previous value, and then we have some code to the right of the comma. So remember, anytime we have an if, this is part of the Boolean logic that we'll be getting into. Anytime we have an if, the comma after the if acts as the word then. It takes the place of, it's like a shortcut for the word then. So if this is true, then, that's what this comma here, and only the first comma. This first comma represents the then. So if this is true, then we're going to output whatever's to the right. Look above. On this line here, if the result of our Boolean was true, what are we doing? We're setting a value. Current spindle equals max spindle. In this case, if the value of our if condition is true, this is an output variable. Cur spindle, comma, $. So what we're doing is we're saying if the speed is not equal to the previous speed, output the speed. This is an output line. We can tell because there's an $. This line of code is writing something to the NC file if the result of the condition is true. Now we have another test down here. So here it says if format round last tilt position is not equal to format round tilt position, which is probably the current tilt position, then we call this post block P new underscore tilt underscore index. So if that's true, we call this post block. Otherwise, we call the else, because this is an if-else. Now, underneath this else is what we call a nested if. Because even though we've gotten into this else block, if the other condition was not true, so if this first condition is false, then we skip down to the else. Now, inside the else, we have another if. And it says if format round last index position, so remember before we were testing tilt position, if format round last index position is not equal to format round index position, then we call P new tilt index. And this is a little bit weird because it sounds like the index position and the tilt positions are not getting saved. Either that or the processing of the Boolean logic rules has changed so much that this isn't getting called correctly, which I think is what's really going on here. Because when we look back in Mastercam and we look at these two operations, oh no, front coolant hole, back coolant hole. So they actually have different tool planes. Let's see here. Okay. So he says, sorry about the confusion. Found out where I was doing it. If you post operations 32, 33, and 34, you'll see it. Let's go do it. 32, 33, 34. Oh, shit. That's not it. Alright. Actually, you know what? Okay. One 31. So you're getting a G43 line up to the Z134. Oh, I get what you're saying. And then you're saying then the clearance plane is coming in, and those numbers are different, right? This Z versus this Z. Part of what I can definitely see here, just so you're aware, this may not be true on your machine because it's typically parameter dependent. Anytime you go into G90, G90 or GO, G91, G28, Z0, this will cancel your tool length compensation, your G43. So when that happens, you do need to make sure that you output another G43 to the correct Z value with your tool length, with your H number. But part of what you got going on usually, well, let's check something. Okay, so we got our Z, we got our Z here, we got our Z here, we got our Z here. Save that, and we'll run it through the debugger. Oop. On, don't need to edit, do need to overwrite because we're going to see it in the debugger. So okay, put in some info. All right. Let's see. Let's do it in a couple of different places. All right. like it. So it's pulling in ZR, which is the Z rapid height. So that's where you're getting your this number from, even though this may be a different spot. This is a different spot. Yeah. So this is coming from ZR, which is, this is an extremely old post. So a lot of this stuff, it could be due to tool change after. There's a mechanism in modern posts. So if we go look at a modern 5-axis post, almost every post should have this variable set. Now, we can try just adding it to your post. I have no idea if it's going to break it. It may break your post. It's already got tool change after. So tool change after is already set to 2. We don't got to worry about that. All right, fair enough. Fair enough. We got tool 0 enables calling the tool 0 type post blocks. We got those in there. It's interesting. So that's where this Z is coming out from, the Z rapid height. And then, so this is our 1.3402. Then we got this guy. Let's go over here. This guy. And that's coming from here. Whatever the current value of Z $ is. So that's interesting that Z $ and ZR are different. You can see that here, this is the rapid plane, and then we have this guy here, which is just Z $. And what's even more curious about it is that here's the line that output it with our force Z $. And this is the rapid move that generated that output. So this is the next rapid move after we start up. What can we see about this rapid move? Look at we got what is presumably the X value. How can we tell if it's the X value? Look at the code. Look up above. 1.189.10222, 1.189.10222, and if we look up here, 1.1891. Okay, that's definitely the X value. Minus 1.223 something, that's definitely the Y value. Okay, so we're getting that in several places. That means this is XY. Why aren't we getting the Z output? Well, that's odd, right? So we were getting ZR for our G43 line. But now we're getting Z, but Z says it's supposed to be 0.4402. So that's funky. I definitely see why you're like, hey, why is this weird move coming out, right? So let's see what we can do to trace that down. We know that this is where it's coming out, is in P rapid. Z versus Z. Now this is interesting to me with this else if thing. I think you've got some things that are broken. So the way that, let's do this. We're going to do a save as. Save this as backup. Save another copy of this as an MC post, just as a second form of backup. Okay. And so here's our feeler post. So previous NC line as the Z value you're looking at. No, it doesn't. Because if we look here, this is the current value that output it, 0.440. The previous line has a 1.34, and if we look at our code here, our Z value for Z rapid was a 1.34. Where's the 1.69 coming from? I see a 1.34, I see a 1.34, and I see a 0.4402. Now, are they being added together? I don't think that's quite right if they are, but, you know, that, no, you're fine, and no worries on apologizing. But yeah, these are, this Z value is definitely weird. Something is manipulating its value somewhere. So it's very curious. Now, what I do see is this. I think this is wrong. I think this worked with older versions of MP. Because what happens is we have an else condition, we have an if here, and we have an else here. And immediately following the else is another if. The only way for this to work is it really if we put it in a set of square brackets. Because otherwise the else condition now for MP is considered whatever to the right here. Because there are no square brackets, it breaks this. We're not actually part of the else. Because this could be true. Okay, so we're supposed to skip the else, but we actually end up executing the else. And I think that's kind of what's going on. So when we go through, we're going to look for some of those else's followed immediately by an if. And I bet it's going to happen in several places. Now, this may break more than it fixes. I don't know. Because again, this is such an old post. It has such funky processing that is set up for it. But, you know, we'll do what we can with it. So what we're looking for is an else, comma, followed by another if. Start position 1. So we got the brackets there. Okay, p op comment. You know what we'll do? Search for else. So this is a properly formatted else. It's got brackets. Here's an else that is not properly formatted. And this right here, in order for this to really work, so it has to be on the same line. If it's not on the same line, you need a set of square brackets. So that should be like that. And this should be like that, because this is for this if condition. So we have if here, that's all one if condition, and the result goes down to here. Then we have if, and again we have this weird if else, and it may be that these are actually working for you, but adding the proper formatting should not hurt. So if it does, if it breaks something, we'll know that this is just, I don't want to say it's a lost cause, because we can always fix it. But there are certainly advantages to be gained by going with a more modern post. Okay, so if do loop. We set this, if number of pockets, Q4, okay. Boom, 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 boom. Set up loop, yada, yada, yada. Index amount equals 360 divided by number of pockets, else it just outputs that. Okay, that's fine. Yeah, I mean, this is actually pretty good so far. At least the brackets are there. Indentation just needed a little bit of work. Really not bad, honestly. Really not. I've seen much worse. So no, this is all pretty good. So we've got we got the do loop. Okay, that's good. So let's keep searching for else's. So it's hard to say if this was supposed to be a part of this else. I don't think so. I think it's only supposed to be this, which is the G90. Again, without really knowing how it was originally built, some of this stuff I'm guessing. So, like, not having this as part of the else, I don't know if that's going to hurt it. But the way that MP processes, it would not have been included anyway. So let's go. Do loop equals 1. Okay, so there's if temp is less than 2, we do all this, else let's see if we can adjust this a little bit. Else, that's all fine. Index amount. This is going to come out no matter what, so that's fine. If rotary, else, get the GOG90. And that should be way up there. Yeah, so there. So if do loop goes all the way down to here. Then we have this else. This guy here. Yeah, if cur loop. When you're working with code like this and you've got so many indents, it's really important for you to use consistent spacing. A lot of times for me, this is where showing the white space really does help. And just remember to be consistent about your indenting. So typically when we have our spacing, it's 6 spaces to start the first post line. And anytime you have an if, you indent 2 spaces underneath it. So here we've got another if. If we were to need more nested brackets underneath, then we would need more indented spaces. Since these results are only 1-line results after the then, we can keep doing it like this. Now this guy, you can see, ends with this bracket, so it also needs to be spaced out. And what we have here is we have a situation where everything that's under this if is indented 2 spaces and it shares a common column. Now if we have more ifs after that, we also need more indents. So here this should be 6 spaces. We should need 1 more there. This should be 1 more space. And the only time we don't need to indent after an if is if the result is on the same line as the if. So here we can look and see that we're in column 7 where my cursor is. So if I put my cursor here, it's actually column 8. We're 1 space too many. So I move this and you can see that this now forms the same column. You want to keep that spacing consistent. So we got 2 spaces here. Spacing here is good. Spacing here is good. This again, anytime we have that else and it's not on the same line, then it makes sense to have the sets of double brackets here. Alright, well I'm still looking for those else if conditions. Or conditions like this where we have the else that is followed by a condition on a separate line but no brackets. If it's on the separate line, it's got to have the brackets. Okay, so this should all be same indent. And when we look, you can see that the brackets now line up. The else should have the same number of spots here. So we're column 7. If I look down there, that is column 7, so we're good. And if we want to have this, we either need to have it on the same line as the if, or we need that set of brackets. So and if we look at this bracket, in front of it is column 7, so in front of this one needs to be column 7 there. We've got some other lines that are coming out here. Just make sure they're on the same level. Else, we're just going to move this one after the else, because we can do that. That's fine. So we have this nice big if, then we have our else, and we have the results there. So let's keep searching. That's good. We can live with that. Okay. So if do loop equals 1, we want to do this. Else, it looks like we want to do all of that. I think. Or the else was just to skip something. That's the hard part to figure out. So if rotary, we do nothing. That's pretty obvious. Else we do G90. This we can put after there. If rotary, we're not doing anything. So this is an interesting thing. We have if rotary, do nothing. Else, do G90. So what we want to do is we want to do G90 if we're not in rotary. The way that we normally accomplish that is to say if not rotary, and we use the not function. So that's the way we normally accomplish that right there. Now the question is all of this supposed to follow the else or not? So here we can say if do loop, we're doing all that, else. I just don't think we need this else. P do tool change. So we got a note. Glad you're attempting to look at it. Mastercam reseller ran from it. Yeah, I'm not surprised they ran from it, to be honest. I mean, you got a lot of stuff going on in here. If tool active. We're just going to add them. And I guess we'll find out. You'll have to do some experimenting and see if that made it worse or better. So this stuff here is all for tool 0, else we do all this stuff. So again, let's go back up here and we're going to look for the else's. Else, and that's fully bracketed, okay. Else, we got a bracket there. That's all fine. Yeah, else. So again, we're just looking for those else situations followed by immediately followed by an if. So here this is okay because it's all on one line. But you know what? Let's just make it explicit. Because really that's the best way to do it. Anytime you've got an additional condition following an else statement, it should always be inside brackets. It's just a good way to do it. Yeah, here's one of those situations. If rotary, do all this, else. PEOF. It's again, this is one of those conditions, this is one of those situations where we just don't need the else. So it's like, if rotary's on, we want to cancel all the rotary stuff. But we always want G90, M1, M30. We always want that at the end. So we're just going to get rid of that. So if rotary equal off. That looks good there. Because you can have an if statement with no else statement. That's perfectly valid. Oh, we don't want that. Let's see. Oh, oh. So this is an or clause. So if this condition or this condition, then do this. And once again, I always like to have this be explicit. So if that's true, we're going to do whatever in the brackets. Else, we're going to do that. Oh, this is ugly. So look at this. If ccomp's not 0, we do this. Okay? Dandy. Then we have this else. But there's no final close bracket. We have a set here. We have a set here. But we probably, God, it's so hard to say. So this is output or output or output. This probably wants to happen regardless. So what we'll do is put the close bracket there. That looks probably right. If that's true, or if this is false, then we're going to do this. And if this is false, then we're going to do that. So we will get output eventually, and then we're saving these values at the end of the post block. That's my guess on how they were intending this to work. If that or that, we get this. If this is true, we get that. Okay, be rapid, yeah. Else, see, here's the else if. So what we really want is this, and I think this is why you're getting your bad output right here, because I think we've got an if condition with the results in brackets, and then we have this else condition, but we really want to wrap this, because in order for this else to happen, it has to get into something, and then it checks the if condition. So, yeah, that's good, that's good. Let's keep searching for else. Okay, that's got brackets, that's got brackets, that's got... that's still okay. Else has got brackets. This else has got brackets. We're good there. That one's okay. That one's now fixed. That one's okay. So again, by okay, what I mean is that the result of this being true, we're going to do whatever to the right. And if it's not to the right, if it's below, it's got to be bracketed. You know what? I think that's kind of all the else's. Yeah, that's all the else's. So let's see if I just broke the crap out of it or what? Yeah. Didn't change anything, at least as far as I can tell. Let's close it and just try it one more time. Okay. So we didn't change anything yet. We run it through the debugger. Okay. So really what I wanted to see was this guy. Okay, keep going. Here we go. Yeah, this is where we're building ZR, and this is inside P start position. Let's see here. So let's put in a breakpoint there. We're going to set a watch. Oh, come on. Let's try doing this. We don't really care about X, so Z, R, $, and we want a watch on Z $. So we got ZR, we got Z. Let's put another watch on Z NCI. Let's restart. Let's just go check one thing as well. Let's go find Z $. So Z $, is where we're getting that funky output from. So sometimes I'll go through a post and just search for every instance of that coming out. So we're still kind of in P break line. Currency equals Z. What I'm looking for is anywhere where Z might be getting set, really. So if we start at the beginning, here's Z $. There's TOSZ. Here it is in P break-lin. Currency equals Z. So I'm just looking at the different places where Z is getting set. See if there's anywhere. So I don't see anywhere where we're specifically setting Z $. This means that either MPDLL is setting it for us, or there could be a bit of vector magic going on where we're actually setting X $. And sometimes when that happens, if we're using vector equate, it can actually set all three variables at once. I think VEQU is vector equate, and it's not being used in this post. So, find PSOF here. Okay, so we got the PSOF. All right, let's go check something. Let's go do this. We're going to go in the post. Go find PSOF. And we'll set a breakpoint there. We'll set a breakpoint in tool change 0. And we'll set a breakpoint in P tool change. And we'll go repost. Okay, so we play that. We go back to Mastercam. And we go to the post debugger. It's also important to kind of know where you're at. We're at the very top, so I'm just going to hit play so that we can generate some output. You can see right now we're paused at the first tool change. So hit play again. Since the breakpoint's on a line that has multiple output, we're going to have to play each section on that line. So then I hit play, right? We finally got through P tool change. So now we're doing all this stuff. We output all this code, XYZ, XYZ, blah, 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 blah. And now we're back at P null tool change. So right now, what do we see? If I go look, oh, I closed it. Oh, you know, we can go look at the previous output. So we were looking here, and after this 1.3402, we get a 1.6901. If I look at my NC output 5, which is where we're currently processing, check out the variable watch list. Okay, Z $ currently is 0.7900 something. Previous Z is 0.841. ZNCI is different, right? 79 and 84. That's all good. But look at previous ZR, 1.6901. Remember in our code, that was the number we were getting. So somehow this previous ZR is getting set somewhere. That's my guess. Just because based on the numbers, based on what we're seeing, that's what it looks like is happening. Let's single block. So I'm going to go to step statement. We go to the current spindle speed. Current spindle equals speed. We check and see if it's greater than the max. It's not. So we go ahead and we output it. set its values. Okay. P go to start position. What are we looking for here? If we go back here, P go to start position does a lot of this stuff. Yeah, you can see all this in here. So keep stepping through it. See where we've gotten to so far. Oh, NC output 5. So we go ahead and play until we get down to some more stopping. Make sure we didn't output the code that we're interested in. No, not yet. Okay, so there we get our G91, G28Z0. Here we're getting our operation comment. Still got our previous Z, 1.6901. Okay, all this is looking good. We get our Z. You can see that current Z is 1.3402. Previous Z is 1.6901. So if I single step, let's go to start position 1. Okay. Whoa. You can see it right there. So we're processing this G code 0 line. We're processing it through PMX0. And it looks like, you can see it right now, somehow the Z value got set to the previous Z value. Because the Z NCI is right. It's right there. So something's going on with the MP processing, MPDLL. Something's going on to reset that value right there. Because right now, the NCI value is completely different, right? The actual Z value in the NCI is 0.44024, right? Right there. The previous value was 1.340 something. And yet, as soon as we hit PMX0, it got set to the previous Z value. That's very bizarre. That's really weird. So, okay though. Let's do this. Debug, run turbo. Oh, so it was in here. I mean, I can think of some ways to fix it. I just don't know if it's going to screw up anything else. What am I doing this extra rounding times 10,000 thing? It's kind of funky. Easy. PZ rapid. Rapid. I mean, we can try that. Can't remember if it was coming out from here or here. I think it was actually up here. You know, we can try right before we process to reset $$ equal to ZNCI. Usually not. So the question is, could it be modifying Z when it does the rounding? It could be, but that wasn't when I saw it change. So let's pound that out. And if we go back and we re-debug, go back to the Mastercam post. Let's do this. You know what? Okay, we got X and Y on there too. We got Z previous. Alright, so look where we're at as far as processing goes. We do the op comment. Okay, and we're still processing P tilt new index, so we go to P start position. so we're still processing. Keep in mind we're just about at the end of P start position. Okay, so we'll single step. Okay, and if we look, Z $sign 1.3402. Okay, ZR 1.3402. Previous ZR 7901. Previous Z 6901. Okay, that's the previous value, not the current. So single step G43. There's the ZR value. Okay, so once we hit this single step, you notice that we update ZR, previous ZR, because ZR was output. Single step, P next tool. So we single step through here. We set the tool length number. We output the tool length number. I hit single step. Okay, so there's our H1. Now we hit P cool on. So single step, we jump to P cool on. We have 3 ifs to process. 1, it outputs the M08 for us. 2, 3. We hit the E $sign. Okay, so we've output this line. We're setting 3 values. Current X equals XR. Current Y equals YR. Current Z equals ZR. Single step, single step, single step. So we've got P new tilt index is done processing. Go to start position is set equal to 1. So now we hit this else condition. It's not going to process anything. So watch the numbers. So I hit single step. It was when we had just finished processing. So the answer is MP does this. MPDLL is making a modification to the data. It's almost like the previous value is just not set right. Run turbo. Let's finish this off. We are running just slightly over, which is okay. I mean, we started late, but I do want to try and wrap this up if we can figure it out. So let's go back in here. Sometimes we have command variables up at the top, which can really affect how MP processes this code. One of them is no update previous, which I don't see turned on here. I think it could be related to rotex type being missing from this post. I'll try rotex type, see if that does anything for us. We're going to get errors using rotex type. Let's see what we get. Oh, maybe it's already used. Duplicate assignment. Yeah, it's already set. Okay. I was thinking that maybe that was it. Wow, you've got something really funky going on. And it could just be because it is such an old post. Um, I think we're going to wrap up class for now. Uh, and I'll try to play around with it. It may just be that we have to send this into CNC software because it looks like MPDLL is modifying things in the background, and we don't really have control over MPDLL except through using command variables up at the top of the post to set posting options. So I'll have to do some more digging. I love it when there's a nice, pat, easy answer, but this is a funky one, so this is interesting. Yeah, sorry we couldn't really figure out exactly what was going on in this class session, but we'll put this on the back burner for now, and we'll come back to this. Yeah, no, it's no big deal. It's the thing about it is some people may see this as a mess, but this is the tool that you're using to output code for your machine, and if it's not right, then there should be a way to make it right. Whether it is building a brand new post from the ground up or figuring out exactly what's wrong with this current post, it's just code. So, somewhere there is an answer. Yeah, and it is, as Jeremy said in his comment, it is neat to see the old logic. So, here's a walk down memory lane for those of you who haven't dealt with old posts before. This is why I teach the class. It's just because sometimes it's like this is what you guys have, and it gets thrown in your lap, and you're the one who has to deal with it. And it's possible. It's maybe difficult, but it's always possible. So, all right, guys. So, yeah, no, yeah, 2 years old. It is definitely not. Like it says up at the top, MP version 4 is when it was written. So, yeah, it may have certainly been modified last 2 years ago. The last time it was touched. Last time somebody did something to it. But no, this is logic that is Mastercam version 4. So, considering we're at version 21 now, it's a long time ago. So, thanks for bringing it up, though. I mean, honestly, it's a good exercise. It's always good to be challenged, to find something where you don't know the answer. I mean, that's half the battle. I find with posts. A lot of time I don't know the answer, but I know that what they're asking for is possible, and it's a matter of figuring out how to go and get the data you need and figure out how to format it and get it to that NC file. So, all right, well, I think we're going to wrap up for today. Any more questions before I shut down? Well, thanks, guys. Yeah, thanks for showing up, even though we got a late start. Hopefully the stuff that we went through was at least semi-educational. Hope I find that it all helps. Learning anything just helps increase your knowledge about everything. So thanks, guys. Thanks, everybody. Yeah, thanks, Ken, and thanks actually for showing that, man. That was an interesting problem to try and work through, and kind of shows us where the limits of the debugger are. I mean, there's a lot of stuff that was a good part of it. So, all right, thanks, guys. I'm going to shut down the broadcast, and I will see you guys again on Tuesday. Thanks, everybody. Have a great rest of the weekend. Thanks again for showing up. Sorry I had to deal with a flat tire, which was a total pain in the butt. But all right, thanks everybody. I'm shut down. See you guys later.